the probability that it will rain, let's say that this is P of R, probability that it will rain. This is equal to 30%. Now, since we are after the probability that it will not rain, we know that this is the complement of P of R. So we can have this as P of R prime. Probability that it will not So using the formula, we know that P of R prime is equal to 1 minus the probability of R. We have P of R prime is equal to 1 minus 30%. So we have P of R prime, 30%. This is also equal to 0.30. So P of R prime is equal to 0.70 or 70%. So the probability that it will not rain on the next day is 70%. Simple probabilities can only cover the calculations of probabilities of single events. There are instances wherein you are asked to find the probability of 2 or more events happening at the same time. In this case, you have to identify first the underlying relationships between and among the events involved, whether they are mutually exclusive or not. So mutually exclusive events are 2 or more events that cannot happen simultaneously. For example, when you roll a die once, the event that the number will come up is an even number, and the event that the number will come up as an odd number are mutually exclusive events. Because when you roll a die once, you can either have an even number or an odd number. It cannot be both. When 2 events are mutually exclusive events, let's say we have events A and B to be mutually exclusive, then the probability of event A or B happening is the sum of the probability of A, which is denoted by P of A, and the probability of B, which is denoted by P of B. So in symbols, we have the probability of A union B, or the probability of A or B is equal to the probability of A plus the probability of B. Example number 1. A die is rolled once. What is the probability of getting an even number or a 5? Okay, so the first thing to do here is to identify the sample space. So when you roll a die once, the sample space would be 1, 2, 3, 4, 5, 6. We'll let A to be the event for getting or of getting an even number. So the sample points for A are 2, 4, 6. And then we let B to be the event in getting a 5. Therefore, the sample point here is 5. Now, as you can see, A and B are mutually exclusive events since 5 is not an even number. Hence, to find the probability of this one, we have P of A union B equal to the probability of A plus the probability of B. Now, the probability of A is, out of 6 numbers, we have 3 outcomes, or out of 6 outcomes, we have 3 outcomes for event A. So therefore, the probability will be 3 over 6. For this one, there is only one outcome. So we have 1 over 6. So adding this 2, we have the probability of A union B is 3 over 6 plus 1 over 6 equal to 4 over 6 for 2/3. Therefore, the probability of getting an even number or a 5 in rolling a die once is 2/3. Example number 2. A coin is tossed 3 times. Find the probability of getting all heads or getting a head exactly once. Recall that when you toss a coin 3 times, you have a total of 8 possible outcomes. And this is the sample space. So now, let A be the probability, or let A be the event of getting all heads. So that is H, H, H. And let B be the event of getting a head exactly once. So that is T, H, T, 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 H, and H, T, T. Now, the probability of getting, or the probability of A is 1 over 8. And the probability of B is 3 over 8. So the probability of A union B, or the probability of A or B, is equal to the probability of A, which is 1/8, and the probability of B, which is 3 over 8. So that is 4 over 8 equal to 1. So the probability of getting all heads or getting a head exactly once when you toss a coin 3 times is 1/2. Example number 3. From a bag containing 5 blue balls, 3 white balls, and 8 red balls, 1 ball is drawn at random. What is the probability that the ball is either white or red? And what is the probability that the ball is either red or blue? So first, we identify the number of the outcomes for our sample space. So since there are 5 blue balls, 3 red balls, and 3 white balls and 8 red balls, you have 5 plus 3, that's 8 plus 8, so you have 16. And then of course, you have the outcomes for blue, you have 5. The number of outcomes for white, you have 3. And the number of outcomes for red, you have 8. Okay. So for letter A, what is the probability that the ball is either white or red? So we need to say we are after the probability of white or red. Remember that P of blue is 5 over 16. And then P of white is 3 over 16. And P of red is 8 over 16. Since we are after the probability 13 over 16. So the probability that the ball is either red or blue is 13 over 16. We learned about mutually exclusive events. These are events that cannot happen at the same time. Now, how about for events that can happen simultaneously? These are called inclusive events. So today, we will talk about the probability of inclusive events. An example of inclusive events is when you roll a die once, and then you let A to be the event of getting an odd number, and B be the event of getting a number less than 5. So these events are inclusive events because when the number 3 comes up, both events A and B are happening at the same time. The probability of event A or event B happening such that A and B are inclusive events is equal to the probability of A plus the probability of B minus the probability of their intersection A intersection B. In symbols, you have the probability of A union B, or the probability of A or B, given that A and B are inclusive events, is equal to P of A plus P of B minus P of A intersection B. Example number 1. A dice rolled once. What is the probability of getting an even number or a number greater than 2? So the first thing to do here is to identify the sample space. So we have 1, 2, 3, 4, 5, and 6. And then we let A to be the event of getting an even number. So the outcomes would be 2, 4, 6. And then we let B to be the event of getting a number that is greater than 2. So we have 3, 4, 5, and 6. Notice that we have common outcomes for A and B. Hence, this tells us that these are inclusive events. Therefore, we have A union or A intersection B, and the outcomes would be 4 and 6. So next we get the probability of each event. So we have P of A is equal to 1, 2, 3, so 3 over 6. P of B, we have 4 over 6. And then P of A intersection B is equal to 2 over 6. Then we use our formula. We substitute our given. So we have the probability of A union B is equal to the probability of A, which is 3 over 6, plus the probability of B, which is 4 over 6, minus the probability of the intersection of A and B. So we have 2 over 6. So the probability of A union B is equal to 7 over 6 minus 2 over 6. So we have 5 over 6. Therefore, the probability of getting an even number or a number greater than 2 when we roll a die once is 5 over 6. Example number 2. A card is drawn at random from a deck of 52 cards. And what is the probability of getting a 6 or a black card? And what is the probability of getting a red card or a card? So remember that since we have a deck of 52 cards, hence our N of S is 52. Now for letter A, we have, let's say that event A, or A is the event that we will get 6. So A. Okay. Now, we know that there are 4 numbered 6 cards in a deck of cards. Therefore, N of A is equal to 4. Now, for our black cards, we know that, let's say that B is the event for black cards. So we know that there are 26 black cards in a deck of cards. Hence, N of B is equal to 26. Now remember that in this 26 black cards, there are two cards that are numbered 6. We have the 6 spade and the 6 club. Hence, this is the intersection of the two events. Therefore, we can say that these events are inclusive events. So, N of A intersection B is equal to 2. So, the probability of A is equal to 4 over 52. The probability of B is equal to 26 over 52. And the probability of A intersection B is 2 over 52. So we have the probability of A union B is equal to 4 over 52 plus 26 over 52 minus 2 over 52. So P of A intersection B is equal to 30 over 52 equal to minus 2 over 52. So we have A union B to be equal 28 over 52, or this is equal to 7 over 30. So the probability that we will have a 6 or a black card from a deck of cards is 7 over 30. B. So we have